Alberta as well. We are part of the Carbon Leadership Forum Alberta Hub, which is part of a larger organization across the world with goals to empower the industry to radically reduce embodied carbon in buildings and in infrastructure. We want to do a special plug for our hub sponsor, which is Dialogue for 2023. So thank you so much to Dialogue for making our webinars and events free for this year. As a note of that, we do have our previous events on our YouTube video, or sorry, on our YouTube that will be available after this. So if you wanted to go back and take a look or look at our other information from previous embodied carbon discussions, that is available there. You can also visit our website to learn more, which is carbonleadershipforum.org, which provides you with information on case studies, policy information, and for specific updates at our hub, you can visit clfalberta.com, in which we'll be posting about all of our upcoming events for 2024. Luckily, we had a great 2023. We were able to host a number of amazing educational events, and we actually had our first event in person as well, which was part of BuildX. We were really happy to be able to finally have our first person event and get to see some of the people that we've seen on these webinars. So we really look forward to bridging these gaps and working more with you in the 2024. So now we're on to our main event. So I'm really excited for this discussion here. We have Stacy Simpson and Gale LeBlanc here from USG, which are going to be talking about circular economy. I met these two people in person. They're absolutely lovely, and I know this is going to be an absolutely great event. So I'd like to hand this over for you so that you can introduce yourselves and start the process.
Thank you, Christina. I'm Stacy Simpson, and I'm the Sustainability Manager at USG. I've been with USG for about 10 years now, and I touch everything with sustainability, from corporate sustainability to product sustainability. And now I'm going to pass it over to Gale to introduce herself.
Hi, everyone. I'm Gale LeBlanc. I am the CGC Ceilings rep here, located in Calgary, but my territory is Alberta, Manitoba, and Saskatchewan. And I work closely with Stacy on any kind of sustainable questions that we have from the architect and A&D community. And so you're in good hands. Stacy's going to kick it off and give you a little bit knowledge on what we choose today builds tomorrow. Off you go, Stace.
Thank you. Just a quick note. I am sick, so please excuse the sniffling and the sneezing and the occasional cough. 'Tis the season to be sick, and unfortunately I have a cold. But moving on, I would like to give you a little bit of information about USG. USG is headquartered in Chicago, and we have been the leading manufacturer of building products and innovative solutions for more than 115 years. We're very well known for inventing the modern wallboard. You can't say wallboard usually without saying sheetrock. CGC, our Canadian counterpart, was linked to USG in the late 1920s. We have a research facility in Libertyville, Illinois, and we do make an array of building products from wallboard to structural panels to joint compound, a lot of finishing products. USG was actually purchased about 4 years ago by Knauf. So today we are going to talk about circular economy. I'm going to go through just the textbook definition, the construction problem, what's keeping us from circular economy thinking, take back programs that we as manufacturers offer, product design, embodied carbon, building life cycle assessments, and what the future holds for circular economy. So circular economy defined, a circular economy keeps materials, products, and services in circulation for as long as possible. It involves manufacturing processes and economic activities that are either renewing or reformative. The aim is for the elimination of waste through design of materials, products, and systems. It is a change from the linear model in which resources are mined or synthesized or extracted. The product is made and then becomes waste. The circular economy reduces the effects of climate change as well as waste, pollution, and challenges the mindset that resources are infinite. So for the building sector, the circular economy principles must be at every level in the building process. When applying circular design principles, the idea is to actually close the loop by identifying the output of one system and connecting it to the input of another system. Without cooperation at every step, it's not going to happen. I'm going to go through each responsibility or each principle. So for architects and designers, you provide and sell the vision to the building owner. So circular design actually starts with them turning concepts into designs. Architects must select the right materials, which takes a lot of research. They must design for adaptability and flexibility to create spaces that can be easily repurposed to meet the needs of a building that is constantly changing. Designing for flexibility is just so important since it helps reduce the need for constant renovations. So much goes into the design of a building that can actually be tied back to circular economy, such as energy efficiency, natural lighting and ventilation, incorporating passive design strategies like proper insulation, natural ventilation, and solar orientation is essential. Also, even considering integrating on-site renewable energy systems like solar panels or wind turbines. Now, for contractors, there must be communication across the job site. Contractors actually own the job site and are responsible for waste management planning. The contractor is responsible for implementing processes for handling and storage materials to reduce damage and waste, such as protecting materials from the elements and making sure the materials are properly stacked and that they're organized to prevent waste. The contractor is tasked with establishing a recycled program on site and to actually segregate and recycle construction waste. Then on to the manufacturer, and the manufacturer plays a very big role in circular economy. We must design manufacturing processes to minimize waste and consume less resources. And this is achieved by designing products and processes that are very efficient. They have to consume few raw materials and generate less waste throughout their life cycle. The manufacturer must understand the life cycle of their products. It is imperative that there is a complete understanding of all steps from extraction and production to use and disposal, ensuring that resources are used to their fullest potential and minimizing waste at every step. It's important that a manufacturer designs products with recycled raw materials and to be transparent about their processes. As you can see, circular economy in buildings is a joint effort and will only thrive if we work together. So what exactly is the problem with construction and the building industry? So the modern construction standards are based on productivity and huge resource requirements. Construction is deemed one of the most environmentally damaging sectors that tend to follow that dated take, make, and waste model. The demand for new buildings causes the extraction of non-renewable natural resources, causing greenhouse gas emissions and deforestation. Making a building causes land use and energy consumption, and there is really no adequate management of construction and demolition waste. Often valuable materials that can be recycled, like steel, aluminum, stone, wood, and even wallboard, are not properly separated and sent to the and they're just sent to a landfill. Approximately 10 to 15% of resources used to make a building are wasted due to inefficient operations. When it comes down to it, it's a lot of time and effort to be sustainable on a job site. It is just easier to be wasteful, especially when you're meeting deadlines. And we can actually see this through all the facts that are represented on this slide. Well, just because there is a problem with current construction standards doesn't mean that there has been no progress. Recycling or reusing materials reduces disposal and transportation costs, so it could be used more frequently on job sites. Efficient identification and sorting of materials is an important factor in managing the diversion of construction waste from disposal. Job site protocols are actually usually identified in contracts and subcontracts and implemented at the project level by superintendents and project managers. Superintendents and project managers must use product specifications prepared by architects and engineers for diversion rates. Building owners and contractors may also have their own guidelines and policies. So it really is a team effort, and communication is vital. Wood debris can be salvaged and repurposed for new construction products. Cement and bricks are usually crushed and reused. Metals like steel, aluminum, and copper can be sent to local metal scrap yards. And then drywall can either be returned to like a USG manufacturing plant, or it can be incorporated into the soil or other products. Actually, right now, USG Rainier manufacturing plant uses about 10% of the clean wallboard waste back into their manufacturing process. Well, there are 6 different pathways to a circular economy: maintenance, reuse, refurbishment, remanufacture, recycling, and composting. My focus will be on how I can help as a manufacturer. So I will be discussing the specific pathways of reuse and recycling for remanufacturing. The first option is to use a manufacturer's reclaim program, where the product is accepted back to the manufacturer so that the waste product can be turned into a new product. The second option is the reuse of a product at a different job site or location. I am very aware that demo waste is a huge issue, especially for wallboard. But job site waste is also a big area of concern for wallboard waste. The consensus is that 11% of the wallboard purchased for a job will go to the landfill. Through careful planning and design, I have heard some job sites reduce this number to 8%, but that's the lowest that I've ever heard. Most USG wallboard manufacturing plants have had the machinery to recycle manufacturing waste into the wallboard line for over 50 years now. It does take quite a bit of manufacturing to recycle wallboard back into the manufacturing line. So the carbon emission savings from recycling wallboard is going to be mostly from the end of life carbon or when the product is landfilled. It was in January of this year that we developed a public take-back program for all of our wallboard manufacturing plants. And this program has actually been my vision for the past 10 years, or since I've been employed at USG. So as said, in January 2023, we at USG started a public program to take back clean wallboard construction waste or scrap product. This means that the wallboard waste that is coming from the job site is clean, source separated, and is USG branded. I often get asked about why just USG branded wallboard. And we have to warranty the finished product, and we have a very rigorous raw material screening process where we test for impurities and heavy metals. I'm not saying that other wallboard manufacturers don't follow some type of rigorous screening. I'm just saying we don't know. Well, the USG Recycle program is only available for regular and fire-rated wallboard. We are investing in the technology required to recycle glass mat and mold tough resistant boards. But at this time, it's just these types of wallboards that are acceptable. We can only use up to 10% of reclaimed wallboard to manufacture new wallboard, and this is mostly because of the fire rating standard. But when paper is separated from the reclaimed wallboard, there will be no limitations on the amount of reclaimed gypsum that we could actually use back into the manufacturing process. So every USG wallboard plant has the resources or the technology to take back wallboard waste. Right now, we have 3 functioning manufacturing plants in Canada, and it will soon be 4. So I wanted to share some best practices from successful customers. Sorting has been the most difficult task since it is very difficult to keep waste from co-mingling on the job site. To maintain that, the container only contains wallboard scrap. Most jobs just assign an employee to police the containers. Another customer had a plan to partner with a waste container hauler, and instead of sending each load to the plant, they plan to use a dump hub and then deliver the job site waste wallboard to the manufacturing plant when the actual large container was full. Oh, demolition waste options for wallboard. We do not currently have a wallboard demo waste program available, but I did want to mention options for wallboard demo waste. Anyone who has ever been to a demo construction job site understands the abundance of wallboard waste. Wallboard is frequently used in buildings and is approximately 14% of the demolition waste. Construction wallboard waste is usually free of contaminants, so it makes it a lot easier to use back into the manufacturing process. Demolition wallboard, it's possible that it could be contaminated with toxic substances such as lead paint or even asbestos, depending on the age of the building. Contaminated wallboard waste does not have many options. It usually has to be landfilled. But for demo waste that is not contaminated, there are some recycling options, such as it could be recycled into cement or flea powder or grease absorbent, athletic field markers, and even animal bedding. Now I am shifting from wallboard to acoustical ceiling tiles. So we have been recycling demo waste ceiling tiles since 2009. We remanufacture the waste material into new products. The process for recycling is a bit stricter than the wallboard, and this is just due to the nature of the material. The used ceiling tiles have to be stacked on pallets and secured for transit. And then USG will cover freight for full truckloads. So the majority of our ceiling tile products are recyclable. We cannot take back fiberglass, wood, or painted panels. And of course, we can't take back any type of hazardous material. We are aware that not everyone can participate in manufacturer take-back programs. It is a program that takes more manpower and time, so it will be challenging. So we do not have manufacturing plants by each major city or development. So at a certain distance, the reduction in carbon emissions will be a bust, and it will not be worth it. If taking back to a manufacturing plant will cause more environmental harm, then we will be forced to refuse the drop-off. So fortunately, this has not happened yet, but we do see this as a scenario that we may face in the future. So moving on to product reuse. So reuse is simply the reuse of a product without transformation. If you are looking to target carbon reduction in a building, this is the way to do it. When you reuse a product, you are eliminating not only the raw materials, but the manufacturing and packaging carbon emissions as well. This is an area that demands innovation and a different mindset for design. For manufacturers, we create a product that is resilient enough to be able to be disassembled and withstand re-insulation. A product's life is no longer a straight line from being produced to being consumed and then discarded. For building designers, it demands a change in mindset and a good understanding of the product's function. But I wanted to show some real life examples of product reuse. Doors Unhinged is a US-based company that sells reclaimed commercial doors. They actually have over 700 reclaimed doors in their inventory. And the doors shown in the finished interior were actually brand new when they were rescued from the previous job site. What happened is that they were ordered new and delivered to a project nearby, but the building owner didn't like them. So the brand new doors were actually headed for a landfill, and luckily they went to a new job site. And the other picture in Mexico, this is a hotel that is made from huge concrete pipes. The pipes are 8 feet in diameter and serve as personal little rooms, and the exterior of each cylinder is unchanged, and it has that rough and textured finish that a concrete pipe does. More examples. Bricks can be easily reused in all buildings. The example I'm using here is Brooklyn, and it's composed of 11,000 salvaged bricks from a warehouse demo. The use of recycled timber is becoming more common, especially for like project landscaping and perhaps decking. The main benefit of reusing timber is the fact that no additional trees are cut down. An excellent example of reclaimed timber is the reclaimed redwood slats used here on this elevator bay at a children's hospital. So a circular economy is aimed at eliminating waste and promoting the continuous use of resources. Using recycled materials is another way that a manufacturer can support a circular economy. Using recycled raw materials removes the extraction and transport of new raw materials and the carbon emissions associated with these processes. Packaging is one of the most difficult areas when considering circular economy processes. Everyone owns something that is plastic. It's a material that is everywhere. Unfortunately, even in our oceans. The major problem with packaging plastics is the functionality. Most plastic packaging is manufactured and treated as a single-use item. Unfortunately, the problem with packaging goes even deeper, since the infrastructure to recycle plastics is really non-existent. even when plastic is recycled, it is expensive to collect and sort. There are thousands of different types of plastic, and none of them can be melted down and processed together. Plastic also degrades, and the more plastic is reused, the more toxic it becomes. Plastic manufacturers have little to no incentive to recycle or reuse their products at this time. It's far less expensive to manufacture most types of plastic from scratch than it is to recycle old plastic into something new. Companies must commit to using post-consumer resin or an alternative like cardboard wherever possible. So I tend to look at circular economy as a holistic approach. It addresses two very important issues at the same time. We reduce our carbon emissions or embodied carbon of products, and we reduce the use and waste of our planet's finite materials. Embodied carbon looks at the carbon emissions that are generated by the production of the building itself. This covers the extraction of the raw materials that are used, their transportation to a manufacturing facility, manufacturing, the transportation of the products to the construction site, and the installation of the products. Well, efforts to reduce the environmental impact of the construction sector have long focused on operational carbon, but due to the rapid decarbonization of the energy sector, which is the greening of the grid, which is occurring at a rate of 4% per year, embodied carbon is becoming recognized as a dominant source of carbon emissions. Several strategies can be employed to reduce embodied carbon, such as participating in manufacturer take-back programs or reusing materials. The carbon emissions associated with the product disposal and the use of new raw materials in manufacturing, of course, will be avoided then. We cannot achieve the emissions reductions necessary to avoid the worst impacts of climate change without implementing circularity. So it is our job as manufacturers to be transparent about the embodied carbon of products. We produce life cycle assessments and publish environmental product declarations to provide the environmental effects of manufacturing, which includes the reporting of embodied carbon. We also are responsible for displaying our EPD information on third-party sites like EC3 tool and within our BIM models. So this is just for demo purposes only. I wanted to just display the differences in embodied carbon as more reclaimed material is added to manufacturer wallboard. It is USG's long-term goal to recycle all gypsum board. This would be both clean waste and demo waste. So at some time, no gypsum board would be landfilled. So this is an example of a real-life job that participated in the wallboard recycle program. The job site in Des Moines, Iowa, recycled 20 tons of USG wallboard job site waste back to our plant in Sperry, Iowa. And it actually resulted in a decrease of the A1 to C4 carbon by 17%. So building LCA is a science-based method for quantifying the lifetime environmental impacts of a building. It is used to measure and reduce the embodied, operational, and whole life carbon of buildings. It is often needed to achieve green building certifications and comply with regulations. A building LCA is the most efficient tool available to measure circular ideas as well as the embodied and operational carbon emissions of any construction project. A building LCA is part of planning regulations in many countries like Sweden and Netherlands and France. And it is incorporated in several building certifications like LEED. So where do project teams start? There's an opportunity at every design phase to incorporate procurement standards, like the reuse of materials. At the concept design phase, it is helpful to use a cost estimation tool or model with Carbon Design 3D. I have found Carbon Design 3D to be useful since not much information is needed to just get like a rough estimate. A comparative LCA can be performed at the detailed design stage and uses more accurate and relevant data. Then the most accurate data is performed after the construction and procurement stage using the actual building metrics and the EPD results for all the building materials that were used in the building. So reviewing circular economy and what is the future for manufacturers. So first and foremost, customer demand drives the building product market. The more customers demand sustainable building material options, the more manufacturers will respond in producing more sustainable building material options. We know we need to close the gaps, and there is a lot of work to do. Products need to change to use less resources, to be more resilient and repairable. Packaging needs to change to not be as wasteful. All in all, there is a lot of work to do for manufacturers. So what's the future of buildings? There are significant system barriers and existing inactivity that must be overcome here. There are market and cost challenges of transitioning to a more circular built environment. Our construction and real estate sector in North America has actually been compared to the fast fashion industry. You know, it's fast, it's cheap, and as a result, it's unfortunately not very resilient. There exists a lack of awareness and understanding of the circular economy as it relates to the built environment. The marketplace for recycled materials is often regional, creating challenges for mass procurement. Inconsistent policies and regulation framework creates challenges. There is a huge inconsistency and lack of care for waste. So what exactly needs to be done? Integrating circular design principles from the very start should be done. Increased education and aware of circular economy, which includes procedures and benefits. More collaboration so that everyone on the job site has the same goal. Leveraging digital technology like BIM modeling and one-click LCA. Then we need supportive policies and regulation because not much will change unless there is a government or state regulations. I did want to mention that we do have a new USG plant being built in Alberta. The USG manufacturing plant will be built in the Wheatland area. The plant will have 100% renewable electricity and will offer, of course, the job site take-back program for the wallboard in that region. The plant is estimated to be functioning in 2026. Well, we at USG released our 2030 goals, sustainability goals in 2022. And one of our goals is focused on delivering a circular economy. So USG has actually diverted over 1.5 million metric tons of wallboard in the past 10 years from going to the landfill. And this is through take-back pilot programs and waste recycling. While we are very proud of our numbers, we are dedicated to continue the research in this area and really innovating to drive the real change. If you are ever interested in using the recycle program for wallboard or have any questions about it, I do welcome you to reach out to me at reclaim@usg.com. And thank you. If you have any questions, I will take those now.
If there are any questions, you're welcome to put them into the Q&A and we can start getting those going.
I guess I could start just to maybe get the conversation going, Stacy. What advocacy can consultants do within the industry or with policymakers to start promoting circular economy as common practice?
I would say building standards, even going there with LEED, suggesting that is a standard that's placed into LEED a little bit more. But unfortunately, it's just we're in an industry where there's a lot of waste, and it's cheap to be wasteful. But I mean, the design and the processes that lead to the circular economy thinking is what's really going to push it. It's going to be the actual innovation in this area.
And I guess related to that, there's a lot of work that's being done in Europe for developing like a product circularity data sheet. Are you hearing anything similar in North America? Any initiatives?
I am not. Right now, I think that we are kind of new to this subject, even though it's a subject that's been around for a very long time, we're still kind of dabbling in it. But I do know EU has a lot more regulations than, we do in North America. So perhaps one day we'll be there.
And for consultants like myself and others on the line, do you have any guidance for us, or best practices? Like, are we able to start specifying these in our specs, to start requesting minimum percentages of recycled content?
The recycled content is very regional, at least for wallboard, and it's hard to sometimes meet those specifications. And if we did, it might be a increase in carbon, if we were to send that material across, 500 miles. I believe that there's a problem when customers start specifying a certain wallboard from a region. It could create some more additional problems.
Okay, that's great to know. What about any advice you might have from a consultant's perspective and dealing with a contractor or an owner that doesn't necessarily know the benefits of circular economy? Do you have any advice for that, of how to advocate for that?
So it's mostly just communication, really, and education. And, there's very small things that can be done at a job site. And there are a lot of resources out there. There's a lot of reclaim facilities that have been opening as example, the one that I gave with the doors, it just takes a little bit more effort for people, and it will be worth it. It does reduce costs, and of course it reduces carbon. So I would just say, research your area, because what you might find might surprise you.
Are there any other questions that anybody in the audience would have here? Well, I want to thank you both so much for today's discussion. This was absolutely wonderful, and it's great to hear that there is going to be additional resources in Alberta that can help contribute to this. It's great to hear about this.
Absolutely. Thank you for having me.
Excellent. And just as a reminder for those who are fans of CLF Alberta, we would love for you to subscribe to our mailing list. So you can go to clfalberta.com in order to subscribe to our mailing list and to find out about our future events and all the awesome items that will be happening in the new year. We are going to be, we are on LinkedIn as well as on YouTube. On YouTube, you can find us under CLF Alberta Movies, not necessarily movies. We are just some webinars here, but we will be able to post this, as well as our previous events are listed up there for those that are just starting their journey into embodied carbon. And again, thank you, thank you, Stacy, and thank you, Gale, so much for your time today. Amazing presentation. And just another quick plug as well to Dialogue for being our hub sponsor for 2023. We really appreciate all the work that they've done with us.
Thank you, everybody, for attending. That's great.
Yep, thank you.